Hello everyone, here is today's problem. Suppose a, b, c are positive such that the sum is 3. We are asked to prove that a over b squared plus 1 plus b over c squared plus 1 plus c over a squared plus 1 is at least 3 over 2. We have shown a similar inequality yesterday and now we try this today. At the end of the video, we will discuss more general case. So as usual, we let J to be the expression on the left hand side. First attempt, we see that for the denominator, we have b squared plus 1. And we know that b squared plus 1 is greater than equals to 2 square of b squared and 1 and equals to 2 modulus b, which is exactly equals to 2b because b is positive. Similarly, this is true for c squared plus 1 greater than equals to 2c, a squared plus 1 greater than equals to 2a. However, this will show that j will be less than or equals to a over 2b plus b over 2c plus c over 2a. And we also know that for the expression on the right hand side, it is greater than or equals to 3, the product of power 1 over 3, that is a over 2b, b over 2c, and c over 2a, which will give me 3 over 2. So we are unable to know which one is bigger. J is bigger or 3 over 2 is bigger, which means that this is not suitable for this question. We also note that for this attempt, we haven't used a condition that the sum of ABC equals 3. Next, we note that a over b squared plus 1 can be written as a b squared plus 1 minus ab squared over b squared plus 1. That will give me a minus ab squared over b squared plus 1. So from what we have just now, b squared plus 1 is greater than equals to 2b. Then this expression is greater than equals to a minus ab squared over 2b, which will equals a minus ab over 2. So similarly, we will have b over c squared plus 1 is greater than equals to b minus bc over 2. And also c over c squared plus 1 is greater than equals to c minus ca over 2. So with this, we have j is greater than equals to a plus b plus c minus half of ab plus bc plus ca. And since a plus b plus c equals 3, so we just need to show that ab plus bc plus ca is less than or equals to 3. And this is not difficult to prove because a squared plus b squared greater than equals to 2ab, b squared plus c squared greater than equals to 2bc, c squared plus a squared is greater than equals to 2ca, which means that the sum of square greater than equals to ab plus bc plus ca. And also a plus b plus c equals 3. The square of it is equals 9. The square of sum equals to sum of the square plus double of AB, BC, and CA. And since the square of sum is greater than or equals to AB plus BC plus CA, this means that 3 of AB plus BC plus CA is less than or equals to 9, which means that AB plus BC plus CA is less than or equals to 3. And we are going to use this back to this, and therefore j must be greater than or equals to 3 minus 3 over 2, which is 3 over 2. And hence we prove the inequality. Obviously, equality holds if and only if a equals to b equals to c equals to 1. So this is a question for yesterday. We proved the question for yesterday, and now we also prove the question for today. So people may ask, will it be true when we consider a over b to the power n plus 1 plus b over cn plus 1 plus c over an plus 1? will it be always greater than equals to 3 over 2? And the answer is obviously no. Why is it so? Suppose we have this condition and we let k to be the expression. Suppose I choose n to be a very big number and a to be a number that's slightly more than 1, b is a number that's slightly more than 1, and c is the remaining, and this will be slightly less than 1. A to the power of n and b to the power of n will be a very big number. In this case, a over bn plus 1 and c over an plus 1 must be a very small number. And therefore, in this case, k is about b over cn plus 1. And sin is less than 1, so c to the power of n will go to 0. So this one is about b. And obviously, b is less than 3 over 2. Back to here. If n is a big number, then this is not true. So how big is considered a big number? If you use a truth like Wolfram alpha, then we know that when n is 8, the minimum of this expression is no longer 1.5. That's all for today's discussion. Hope you enjoyed it. I'll see you again next time. Bye bye.